Morning, algebra class. This is Mrs. Warren, and I am going to be your video of notes for today's lesson. So make sure you have a piece of paper out and you are ready to write down exactly what I am writing down. Because remember, you'll be turning it in so I can see that you did your notes. And today's topic is a little bit tricky. So it is important that you really pay attention, pause, rewind if you need to hear something again. And yeah, let's dive right into it. This is section 3-6, but it is 3-6B. It's the second part of 3-6. We did the first part last Thursday. And today it's all about interval notation. Now, interval notation is one of these things that shows up now, and then you won't see it again until Algebra 2, but you will see it again, and it is an important notation for us to begin to get familiar with. The backside of your test in 2 days is all interval notation. The front side is solving your compound inequalities, and so you have an entire backside of a test that includes interval notation. So what is interval notation? Well, good question. Okay, so let's kind of back up before we dive into what exactly interval notation is, and let's look at the inequality. X is less than or equal to 3. Let's just look at it for a second. This is a set of solutions. I mean, think about it. It's everything that is less, any number, decimals included, fractions included, any number that's less than or equal to 3. I draw my line here, and if I were to graph these, if I asked you to graph these, you guys do an excellent job of graphing, by the way, as a class overall. I would put a closed circle, let's use a different color. I'd put a closed circle on 3, and then I would shade everything to the left, because it's everything less than or equal to 3. Okay, so this right here, I think we can all agree that this right here is a visual of the solutions. It's like a way for us to see it. Kind of like if I were to draw a picture of the solutions, this would be my picture. Not as beautiful as some of your guys' pictures, but it is. It's a visual. It's a visual of our solutions. So now as we get into interval notation is another way to represent interval notation. It is another way to represent our solutions. Represent our solutions. You might ask, why do we need another way to represent our solutions? That's a great question. And one that will be answered in Algebra 2. But for now, interval notation, it's kind of like how in the English language, when we write a sentence, there's different ways to end our sentence. We can use a period or a question mark or an exclamation point, depending on what we need for that sentence. Interval notation, you can think of it that way. We have our inequality, which is one way to notate. We have our graph, which is another way to notate. And we have interval notation, which is another way to notate. And what interval notation does is it describes, really what it does is it describes an interval on the number line. Think for a second. In fact, pause the video if you need to and Google what the word interval means, just in general. Okay, so now that you know what interval means, maybe you saw, I think of intervals like time intervals sometimes, like you can, like, the delivery man will be there between 7 a.m. and noon. That's an interval. That's a time interval. So it's a portion of something. So what we do is we use 3 special symbols. And we're going to write what those three special symbols are right here. Now, the thing about interval notation, you guys, is it just takes a little bit before we grasp it. This is like brand new to you. You don't have any past experience to pull from with interval notation. So it's going to feel strange. And I want you to just embrace how it feels strange. So here's the first symbol, parentheses. Which is always a hard word for me to spell. Okay, now parentheses, we know what parentheses are. We've seen them in math, but they have a new context here in interval notation. And we use our parentheses, either an open parenthesis or a closed parenthesis, when a less than or greater than symbol indicates that the interval's endpoints are not included. Okay, that's a lot of words. We're going to refer back to it in a minute. So just hang on to that. The second special symbol are brackets. And you may have seen brackets. You may have seen it in PIMDAS. I think Mrs. Lippert used brackets a lot. So if you were in her class last year, you would have seen brackets. But this is what a bracket looks like. So we use a bracket, an open bracket or a closed bracket. Very different than a parenthesis in math. They mean two completely different things in this context. When a less than or greater than symbol indicates that the interval's endpoints are included. And then there's one more symbol that is, you might actually know this symbol already, which would be kind of cool. The third symbol is infinity. Did you know that infinity has a symbol? It does. And we use the symbol, looks like this. It kind of looks like a sideways 8. My math professor would always write it like that. But I like to do the full loop-de-loop. When the use infinity, when the interval continues forever in a positive direction. Now, don't worry, we're going to do examples of all of this. What about if it goes in a negative direction? What would we use? Well, I'll tell you. We'd use a negative infinity. That is a thing. When the interval continues, oh, that was messy, forever in a negative direction. Okay, these are our three symbols. And the next thing that I'm going to do in our notes here is show 4 examples of how we use parentheses, brackets, and infinity in actual interval notation, because right now you don't even know what interval notation looks like. So we'll come back to those parentheses, brackets, and infinity symbol. But we're going to look at 4 examples, and it's going to be kind of a chart here where we're going to have inequality. We're going to have our graph, which are the 2 things we already know, and then we're going to have our interval notation over here. I don't think I've said this yet, but I actually really love interval notation. I think it's kind of fun to do. I think some of you, once you grasp it, will also like it. I could see that potential happening. And I just really don't think pink and red go together. So let's do a different color here. What color goes with pink or with red? How about yellow? Mr. Warren's over here. It's the morning. School hasn't started yet on December 2nd, and I'm writing your notes. So here we go. Inequality. X is greater than or equal to 2. Cool. Let's graph it. We know how to do that. Here's 0. Here's 1. Here's 2. Here's 3. Be a closed circle on 2. And it's everything going to the right. Okay, so interval notation. You ready for this? Here's how we do interval notation. We read our graph from left to right, just like we do in the English language. We read everything from left to right. And in interval notation, I am going to represent what's happening with just the arrow part, because I just care about my solution. So I'm just looking at my arrow part. And that's how I'm going to represent interval notation. Now, if we look up here, it says that brackets are used when we have a less than or greater than or equal to, and parentheses are used when it's not, kind of like our open and closed circles, which means my solutions begin at 2. And so the way I'm going to do this, watch very closely, is I'm going to have a bracket beginning with my solutions, and I'm going to just write the number 2 and put a comma. And this represents that my solutions start at and actually equal 2. And my interval, like this, I'm going to put something else here and something else here. And that's going to represent what happens to my solutions as they go on forever. And so let's think about it. What's the very last number that my solutions go to? Well, if you said, Mrs. Warren, it goes on forever, you're correct. So the number, and this is kind of a weird concept here, is infinity, which infinity is a number. We treat it in math as a number. When you guys hit calculus someday, it's all sorts of cool stuff with infinity. But does it ever land on a final number? Does it ever actually equal infinity? No, it doesn't, because we can't. We can always add one more. And so we end it with a parenthesis. And that's our interval notation. If you need to pause, rewind, watch that again, do it. I am going to do 3 more examples, though. You guys, if that just kind of blew your mind and you were like, Mrs. Warren, I do not know what you're doing, that is a very normal response, and almost everybody has that response the first time. And what ends up happening is, as we see more examples, you kind of start to get it. So just hang in there. Okay, let's look at another one. Let's do x is less than 2. Notice our sign changed direction, and it's not equal to anymore. Okay, using a different color here. We are going to do an open circle on 2, and it's going to be everything to the left. Okay, now here's the crazy thing, you guys. We read our graphs left to right. So I start over here on the left, and I think, what is the furthest left solution of this set of solutions? What's the furthest left solution of these solutions? If you thought negative infinity, you thought correctly. And because my solutions never land on negative infinity, I actually start with a parenthesis. And I start with negative infinity. I'm writing my graph left to right. And this is the furthest left number. Furthest left number. That might be helpful for you. Furthest left number is negative infinity. So then I keep going to the right, and where do I end? Well, I end really close to 2. I don't quite end at 2 because it doesn't equal 2. I can get really, really close to 2. But because of the way interval notation works, we can actually write 2. I need to close my notation, but do I close it with a bracket or a parenthesis based on what we wrote above? Think about it. Does it actually equal 2 ever? No, it does not. And so I end my interval notation with a parenthesis. And this is my interval notation for x is less than 2. That kind of looks like an ordered pair with graphing. It's not graphing. This is a different context. Just like in English, words mean different things in different contexts. Same happens here with math. Okay, let's keep going. Again, remember, because you're watching a video, You are always welcome to rewind and rewatch. Okay, this is a compound inequality. This is something we just talked about last Thursday. It's funny to say last Thursday because it's Wednesday. It's the day before the day I'm referring to here. That's okay. Think about that for a second. Okay, so here's my graph, and let's graph this. X is greater than 1. I'm going to put an open circle on 1, and it's greater than it, so I have to go that way. But X is also less than or equal to 5, which means I'm going to put a closed circle on 5 and go to the left. So my solutions are in the interval between 1 and 5. Okay, cool. This is a cool interval to write. Let's go over here to write our interval. Remember, we read left to right. So I'm coming from the left over here, and my very first solution is very close to 1, but not quite 1. And so I use a parenthesis to represent the beginning of my interval. Put a comma. And then my solutions go, there's a lot of numbers between 1 and 5. There's an infinite amount of numbers between 1 and 5. Just a smaller amount of infinite numbers than if I kept going on forever. But I do go all the way until 5. And does it actually ever equal 5? The answer is yes. So I have a bracket. By this point in the notes, you should start to kind of grasp what's happening. I would expect that. You should start to kind of grasp what's happening here. Let's do another color. Let's do orange. Okay, let's look at another compound inequality. Let's do an OR situation. So we have x is less than -3, or x is greater than or equal to 4. Now remember, or on a graph, our solutions go opposite directions, which makes a very interesting interval notation over here. Now again, some of you are going to grasp this really well. -1, 0, and some of you are going to need to watch this video, parts of it, a few times, and that's okay. But I want you to lean into it. That's your instruction from me. Okay, so let's start graphing. We can do that. X is less than -3. That would be an open circle on -3, and everything less than -3. And then x is greater than or equal to 4. That'd be a closed circle on 4, and everything greater than. And that should work. That's exactly how it should look for an OR situation. So it's everything that's not in between -3 and 4. And so over here, you guys, for our interval notation, something really kind of crazy happens. We start from left to right, and we notice that the furthest left solution is -infinity. Oh, I have an open circle, and I start with -infinity. And I'm going to go all the way until I get really, 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 really close to -3. In fact, we can just write -3 as long as we put a closed parenthesis. Now notice, I had to put a closed parenthesis because my solutions stop. There's nothing more as I keep going left to right until I get to 4. So what happens is I start with a new interval notation, and I start with a bracket because it does actually equal 4. And notice that it goes on forever here, all the way until infinity. And that's okay. You can have two interval notations representing the same graph. Okay, so now let's look at a few more examples. Now this is your basic examples as far as like, here's what it looks like in how we see interval notation. But now let's look at some examples where you actually have directions. So let's look at some directions here. We know directions are important. They're half the battle in math, and it's important that we read them and analyze them. So here we go. Crazy stuff. What is the graph of bracket -4, comma 6 parenthesis? And then the second part is, how do you write bracket -4 comma 6 parenthesis as an inequality. Okay, two parts to this question. What is the graph? And how do we write -4, 6 as an inequality? Okay, cool. Let's start with the graph. I really do believe that's the easiest part in translating. So if you notice, we're going from, like in our chart up here, we're going from here to here, and then from here to here. So we're going backwards of what I showed you, which is fine. We're just going to take the same logic. It's actually really good for you to practice that because then you can get a better understanding. 3, 2, 1, 0 of interval notation. 1, 2, 3, 4, 5, 6. It's hard to pack and count at the same time. Okay, so let's unpack this. We have a bracket here, which means closed circle on -4. And we read our solutions left to right. And so it looks like I'm going all the way until 6, but does it ever actually equal 6? Nope. So it's a closed circle on 6. Okay, so then that's the first part of the question done. But now we need to write -4, 6 as an inequality. Now, this is an and inequality because my solutions are going towards each other. So my x is going to be in the middle. And I like to kind of look at it at two parts. Like, let's look at this part, and then let's look at this part of our inequality. And so x is, we know it's bigger than or equal to -4. And then we go all the way over here to 6, and we know x is everything less than 6 because it's everything to the left of 6. And there's my inequality. Okay, let's look at another example. Some more directions. What is the graph of x is less than or equal to 1, oh, -1, or x is greater than 2? How, I bet you know it's coming, how do you write x is less than or equal to -1, or x is greater than 2 in interval notation? Okay, so if you see here in the directions, the first thing we need to do is graph it, and then we need to write it in interval notation. Let's do some graphing. The graphing part, I mean, at this point, graphing should be pretty second nature. We should be getting pretty good at graphing our inequalities. And if not, this is great review for you. I think even in your homework, I just put some old school review in your homework, which is virtual today. So we've got x is less than or equal to -1. So that is a closed circle on -1 and everything going to the left. And then we've got an open circle on 2 and it's everything to the right. So the graphing part is done. As far as interval notation, this one's a little bit tricky. It is an or situation, which we saw right here with the word or. And remember, I start from left to right. This is probably the biggest mistake I see with my algebra students every year is that they don't always write their interval notation left to right. Order matters greatly with interval notation. Your order must read left to right. It must. So what's happening over here on the left? Well, it looks like I start at -infinity. That's the furthest left solution. And I go all the way to -1 and have a bracket here. And then nothing, 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 nothing until I get to 2, but it never equals 2. So I use a parenthesis. And I go on forever and ever and ever and ever and ever and ever. Okay. All right. If you guys want more practice, you do have a homework assignment. You can also send me a hangout or send me an email and I can give you more practice. There's a ton of practice in your book starting on page 205 if you have a math book. And so on page 205, you can do the odd problems and check your answer. I'll write that down, page 205, and check your odd answers in the back of the book if you want some extra practice. Remember, today is a virtual assignment, so if you need help figuring that out, please let me know. Feel free to rewind this and rewatch, fast forward, pause, all of that. And I'll be waiting for your questions. We'll review this a little bit more tomorrow, but your test is Wednesday. That covers this. So we gotta lean into this ASAP and really work to understand it. All right. Today is actually December 2nd, the day I'm filming this, but you're watching this on December 7th. But I will see you guys for your other test in a few hours. Adios.